Okay, the sound went out a little bit at the end of part one, so I'll finish it up here and finish up those last two problems. So for part D, what percentage of adults have IQs between 100 and 130? We use the empirical rule to know that 95% is within, this would actually be 70 and 130. And since we know it's perfectly symmetric, that this is equal to this percentage. So we can cut 95% in half to get 0.475 or 47.5%. So that's finishing up part D. The last two problems really aren't dealing with the empirical rule, just how the normal distribution works in general. Part E says, suppose Jack scored 120 on the IQ test. Only 9% of adults score 120 or more. What percentage of adults score between 80 and 120? So I would be limited in the number of questions that I could ask in this manner. But let me kind of give you an idea of what's happening here. So 100 is the mean, and the standard deviation is still the same. It's still 10, but it's not, it's still 15, but that's not relevant here. So we have Jack scored 120, which you may realize already, it's not one standard deviation above the mean, it's not two standard deviations above the mean, somewhere in the middle. And next class period is when we'll talk about how to figure out exactly how many standard deviations it is above the mean. But for right now, it doesn't matter, because we know that only 9% of people score above 120 on the IQ test. So, or 120 or more. So that's 9%. We want to know the percentage of adults who score between 80 and 120. Now, 80 is exactly the same distance away from 100 that 100 is from 120. And since the normal distribution is perfectly symmetric, those would be the same percentages. So if there's 9% here, there's also going to be 9% here that essentially score below 80. The same percentage that score above 120 is the percentage that will score below 80. Okay, and then so essentially we want between 80 and 120, so we have to realize the whole curve has that up to 100% or 1. Add 9% and 9% to get 0.18 or 18%, and subtract that from 1, and you get 82% or 0.82. Okay. So again, if you need to rewind it back to hear that again. So on the last problem, this time it says, suppose Jill scored 125 on the IQ test. Only 5% of adults score 125 or more. So start this out. There's still 100 right there. Okay. But Jill scored 125, and only 5% of adults score higher than that. So what we want to figure out is what percentage of adults score greater than 75 on the IQ test. So greater than 75. So 75, again, I can only ask you a question at this point like this, where they're kind of equally distant from the mean. So 75 is right here. And we want to know the percentage that score greater than 75. So greater than 75 would be everything to the right of 75 here. So what we could figure out is, since this is 5% above 125, this is 5% below 75. Again, they're the same. So if you wanted to find the percentage of adults who score greater than 75, so not this 5%, not this middle portion right here, but everything greater than this, would be everything except this 5%. So it would be 95%, or 0.95. Okay? So again, there's some problems dealing with the empirical rule. There's also a couple of problems just kind of dealing with the fact that the normal distribution is symmetric, and computational problems with area or percentage.